Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here: aromaticity and acidity of cyclopentadiene. Moving on to the next step. Identify the structure. The molecule is cyclopenta-2,4-diene cyclopentadiene. It has a 5-membered ring with 2 double bonds at C2, C3 and C4, C5 and 1 sp3 carbon at C1 bearing 2 hydrogens. The arrow points to one of the sp3CH hydrogens at C1. Moving on to the next step. Consider what happens when the indicated H is removed as H+. Removal of H+, a proton, from C1 leaves behind a carbanion. C1 bears a lone pair negative charge. This carbanion at C1 gives the cyclopentadienyl anion, which has 6 pi electrons, 2 from the lone pair carbanion plus 4 from the 2 double bonds, delocalized over all 5 carbons in the ring. And for the final step, apply Huckel's rule. The cyclopentadienyl anion has 6 pi electrons, 4n plus 2 where n is equal to 1, making it aromatic. Aromaticity provides exceptional stabilization to the anion, making the loss of H+ very favorable. The pK of cyclopentadiene is approximately 16, which is remarkably acidic for a hydrocarbon. Evaluate other options. Removal as H hydride, option B, would give a carbocation, which is a high-energy anti-aromatic, 4 pi electrons, cyclopentadienyl cation, very unfavorable. Removal as H radical, option C, gives a radical species, which is not particularly stabilized by aromaticity. Option D, H2, is chemically nonsensical. Conclusion. The thermodynamic driving force of aromaticity in the resulting cyclopentadienyl anion makes removal of the hydrogen as H+, a proton, the easiest and most favorable pathway. Therefore, the correct answer is A. Therefore, the correct answer is option A.